Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on star to delta transformation technique. Why we need to study this star delta transformation technique? Where do we apply this transformation star to delta, delta to star transformation technique? Why we need to study this one? So first, these are the circuits. There are different network reduction techniques. First, series connection, series connection, parallel connection. To calculate the R equivalent, L equivalent, C equivalent, different techniques for network reduction techniques. Series connection, parallel connection. Another technique is star to delta and delta to star connection. These are the network reduction techniques. Now here, these two are connected in series and these two are connected in series, again parallel connection. So we can simplify easily in this case. And in this case, these two are connected in series and these two are connected in case, and these short circuit and all are connected in parallel. And at this case, these two are connected in parallel and these two are connected in parallel. Next, series connection. Next, here these two are connected in series and these two are connected in series, and then we can simplify easily, again parallel connection. And these two are connected in series and these two are connected in series, and then again parallel connection. Then we can calculate R equivalent easily. Now here, these two circuits are most important. These two circuits. Now here we cannot determine this circuit is okay. This circuit. So how you will calculate? This is okay. This one is also. These two are connected in series and these two are connected in series. And again these three resistors, this one and these three are resistor are connected in series. So this is okay, simply circuit. Now this case, how you will calculate the equivalent resistance between these two terminals? So in this situation, so series connection, parallel connection, we can series equivalent resistance, series and parallel. So we cannot apply here. So for that case, we will go for star to delta conversion or delta to star conversion. These 60, 20 and 10 are connected in delta connection. Convert this delta connection into the star connection first. Then circuit is very simple. This circuit will be it looks like this. This one, and this one, and this one, and this one. This is star connection from delta to star conversion. Now you can see these two are connected in series and parallel and again series connection. So for that case, we will go for delta to star conversion. Star to delta and delta to star conversion. So first here, this is the star connection and this one is the delta connection. Star connection means three elements, each element having two ends, first end and second end, first and second. Each element, one end is connected to one point. That point is known as the neutral point. So second end is of each element is connected to one point is known as a star connection. And delta connection means here each element having two ends, 1, 2 and 1, 2 and 1, 2. First element, second end, three elements are said to be in delta connection. First element, second end is connected to second element, first end, and second element, second end is connected to third element, first end, and third element, second end is connected to first element, first end. So in this way, mesh will be formed. That mesh is known as a delta. If you see the definition here, three elements meet at a node. Three elements meet, each element one point. Each element of one end is connected to one point. So that connection is known as the star connection. And three elements in the form of closed path. In the closed path means that is a mesh. Each element. So now here second element, three elements are said to be. This is the first element, second element, and third element. So first element, second end is connected to second element, first end, and second element second end is connected to third element first end, and third element second end is connected to first element first end. So such connection is known as the delta connection. Now here this is the delta connection, and this delta connection is replacement of this delta connection is replaced by star connection, that is delta to star conversion. Now here the derivation. First I will explain delta to star conversion. So this is the star connection and this one is the delta connection. Star connection I am representing three elements R1, R2, R2 and R3, and next in the delta connection I am representing this RA, RB and RC, three elements. So first in between X and Y and Z and Z and X. Same fashion for X and Y for delta and Y and Z for delta and X and Z for delta. At X and Y terminals R equivalent equation. Determine the R equivalent for each setup. Now here in this case first X and Y R equivalent is, this is redundant branch, R3 equals to 0. It is open circuit current is open circuit resistance is infinity. Don't neglect this resistance. R equivalent between X and Y is R1 plus R2, this one. And next one, this Y and B means at these terminals, this Y and B, and this is redundant. This don't consider this one. This is the redundant. So now at this Y and B, R equivalent is R2 plus R3. Next here this is over. Next at Y, at Z and Y, R equivalent equals to, this is the redundant. Don't consider this one, and R1 plus R3 is the R equivalent. This one. So now we have at three terminals X and Y, R equivalent is R1 plus R2, and Y and Z, R equivalent is R2 plus R3, and next X and Z is R1 plus R3. Three equivalent resistors. Now for delta case also X and Y. So here these two are connected in series and again in parallel with RA. Now here RB and RC are connected in series. So addition RB plus RC, and if two resistors are connected in parallel, so R1 and R2 are connected in parallel means, so now that R equivalent equals to R1 into R2 divided by R1 plus R2. Now this is the RA plus RB plus RC and RA are connected in parallel. RA and RB plus RC are connected in parallel. So now for that case, if you use this formula RA into RB plus RC, RA plus RB plus RC, this is the at XY terminals only. Now see at Y and B terminals, Y and Z terminals. In that case, Y and Z terminals, this RA and RB are connected in series, again in parallel with RC. This is the case. So now in that case, for parallel case, RC into RC multiplied with RA plus RB plus RB plus RC, this one. Now next at Z, X and Z, this one X and Z are equivalent. So these two are connected in parallel, RA plus RC in parallel with RB. Now here RB into RA plus RC, and next RA plus RB plus RC. Now these are the formulas for each case, X and Y, Y and Z and X. Now equate. So this is same. This resistance and this resistance is same, this resistance and this resistance is same, and this resistance and this resistance same. Now here R1 plus R2 equals to RA into RB plus RC divided by RA plus RB plus RC, and next R2 plus R3 is equal to, this is equation number 1. Next RC into RA plus RB, RA plus RAB plus RC. Next here this one, third one, R1 plus R2 equals to RB into RA plus RC divided by RA plus RB plus RC. This is equation number 2. This is equation number 3. Now here 1 minus 2. You do this one. First one, 1 minus 2. So this is the LHS side and RHS side. This is LHS side and this one is the RHS side. LHS side and RHS side. So R1 plus R2 minus R2 plus R3. Actually, if you do this one, 1 minus 2 plus 3, you need to do this one. So now first 1 minus 2. This one. This is the 1. This one and this one is the 2. And this is the RHS side of 1 and this LHS side of 1 and RHS side of 2. RHS side of 1 and RHS of 2. This one. Here, what are the same terms? Here R1 and R2 are same. This equals to R1 minus R2. R1 minus R3. This one. And now RA-RB plus RA-RC. This one. Okay. Next, denominator is same, RA plus RB plus RC, and this one minus of RC RA and RC RB. Now what are the same terms here? What are the same terms? RA, RC and RC RA. These two are same. These two. Now here this one and this one is same. Cancel it. Now this one equals to RA RB and minus RC RB. RA RB minus RC and RB divided by RA plus RB plus RC. This is equation number 4. So now for this you add plus 3. 1 minus 2 plus 3 you need to add. So now here this R1 minus R3 is RA minus RB, RA RB minus RC RB divided by RA plus RB plus RC. This is equation number 4. So plus 3, 4 plus 3 you do. So now plus 3 means this one. This is the 4 and this is the 3. 3 means this one. This is the 4th one. Now here what are the same terms? Here RC RB and RB RC. This one is same. If you add this, denominator is same, RA plus RB plus RC. Now if you simplify it, here 2R1 equals to 2RA 2RB divided by RA plus RB plus RC. Now here 2 gets cancelled. This one equals to R1 equals to RA into RB divided by RA plus RB plus RC. This R1 equals to RA RB divided by RA plus RB plus RC. If you do this, and next case 2 minus 3 plus 1, you will get this one. Next R3 equals to RB into RC divided by RA plus RB plus RC. Next 3 minus 1 plus 2, and this R2 equals to RB and RC, RA and RC divided by RA plus RB plus RC. That notation here you can see here. R1 equals to this, R1 equals to RA and RB divided by RA plus RB plus RC. This is equation number 5 I am giving. And next R2 equals to this, R2 equals to, this is 6 I am giving, RA and RC RA and RC divided by RA plus RB plus RC. Next, R3 equals to RB into RC, that equals to 7. Seventh equation, RB RC divided by RA plus RB plus RC. Now here this is delta to star. These R1, R2 and R3 are star, and RA, RB, RC are delta terms. From the delta terms to the star terms we are deriving. So this is delta to star conversion. Now again star to delta first is delta to star conversion and next star to delta conversion. These are the terms. This is 5, this is 6 and this is the 7. What you will do first, 5 into 6 plus 6 into 7 plus 7 into 5. If you do this first, from R1 into R2, 5 into 2, 5 into 6, LHS and RHS 5 into 6 plus 6 into 7 plus and 7 into 5. This one equals to R1 into R2 plus R2 into R3 plus R1 into R3. R1 into R3 plus and this one 5 into 6 and 6 into 7 and 7 into 5. This one. And RHS side is also same, 5 into 6 and 6 into 7 and 7 into 1. So this one RA, RB. Next this one RA, RB and RA, RC. This one is okay. And denominator multiplication with this is whole square. And next RA, RC and RB, RC. This one. And denominator whole square, RA plus RB plus RC whole square. And this one RB, RC, this one and RA, RB, this one multiplication. And denominator whole square, RA plus RB plus RC whole square. Now next case, this is same as it is LHS side, this one. So multiplication, same equation is here. This one, same equation, RA, RB, RB. RA square. If you take the RA, RB, RC divided by RA plus RB plus RC as a common. Now you will get this one is a common. So this one you will get here RA only, RB only, here RC only, here RB only you will get. That RA, RB and RC. Here you can cancel this one. This one is numerator power is 1 and this one is the 1. Now the final one is the RA, R1 into R2 plus R2 into R3 plus R3 into R1 equals to RA, RB, RC divided by RA plus RB plus RC. Now here what is the formula for RA, RB equals to, what is one, this one, this is R1, this one is the R1, this formula, fifth equation. Now substitute here R1. Now here RC only delta term, RC equals to R1, R2, this one, R2, R3 and R1, R3 divided by R1. Next, similarly for all the cases, next R2 cases, this see what is the value of this one, RB, RC, this one, this is the R3. So for that case, this one. Next case, this one, RA, RC divided by this one, that is R2. In that case, this formula. Now the final conclusions here, this is delta to star and star to delta formulas, delta to star and next star to delta formulas. These are the formulas. Now here you can rewrite these equations. RC equals to R2 R2 plus R3 plus R2 R3 divided by R1. Next, RA equals to this one. RA equals to this RA equals to R1 plus R2. RA equals to R1 plus R2. R1 plus R2 plus R1 into R2 divided by R3. Next, this RB equals to R1 plus R3, R1 R3 divided by R2. Now you can in the shortcut method you can mug up this formula. First R1 equals to this formula first. R1 equals to adjacent resistance RA RB divided by total resistance RA RB divided by RA plus RB. And next this R3 equals to RB RC, this one, divided by total resistance. And this R2 equals to RA RC divided by this one. Next, what about star to delta? And RC equals to this one. RC equals to R2 plus R3 divided by plus R2 R3 divided by R1. And this RA equals to R1 plus R2 plus R1 into R2 divided by R3, this one. Next, RB equals to R1 plus R3 and R1 into R3 divided by 3. So these are the formulas for delta to star and star to delta. By using these formulas, we can simplify any complex circuits if they are connected in star or delta. Now let us take one problem. First, calculate the voltage applied to AB terminals in order to drive a current of 5 amps in the circuit by star delta transformation. This is the circuit. So how you will simplify that one? So that R equivalent, first calculate R equivalent. For that case, 5 ampere current. So now if you calculate the R equivalent, if you multiply with that one, you will get the voltage value. Now here this is the delta connection. Convert the delta connection into the star connection. How you will calculate that one? So that connection is, this is delta and this one is the delta. Now that connection here is here, this connection, this value equals to 2 into 5 divided by this value equals to 2 into 5 divided by 2 plus 5 plus and 3. And this value equals to 5 into 3 divided by this resistance equals to 2 plus 5 plus 3. And this resistance equals to 2 into 3 divided by 2 plus 5 plus 3. And next this one, 10 into 5 divided by 10 plus 5 plus 10. And this value equals to 5 into 10 divided by 5 plus 10 plus 10. And this value equals to 10 into 10. This value equals to 10 into 10 divided by 5 plus 10 plus 10. Now the simplified equation, this value is 1 and this value is 1.5 and this value is 0.6 and this value is 2 and this value is 2 and this value is 4. Now here these three are connected in series and these three are connected in series. So for that case, the series connection, so 1 plus 3 plus 2, that is 6 and 1.5 plus 2 plus 4, that is 7.5. Next these two are connected in parallel, 6 and 7.5. So for that case, so that 7.5 and this one 6 and 7.5. 6 parallel with 7.5 means 6 into 7.5 divided by 6 plus 7.5, that value is 3.33. Now again these three are connected in series. So 0.6 plus 3.33 and 2 equals to 5.93. This current is 5 amperes. If you multiply with this one, and you will get the total voltage, that value is 2.9695. I hope all these concepts are clear to you. The derivation is also, I hope it is clear to you. This problem also. If you still have any doubts in this derivation and in this problem, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.